Alright, learning guide problem number 1, talking about radians. Describe what a radian is, explain why there are 2 pi radians in 360 degrees of a circle, and then draw an angle measuring roughly 3 radians, and explain how we know it is accurate-ish. So, if you think about a normal circle, we know that a normal circle has a 360 degrees in it. That's how we think of it. But a radian is defined as, if that is the length of the radius, call it r, however far you have to travel along the radius of a circle, however far you have to travel so that the length of that arc is the length of the radius, whatever angle that creates is 1 radian. That's the definition of a radius. And so why are there 2 pi radians in 360 degrees? Well, how do you find the circumference of a circle? Circumference equals 2 pi times r. And we're taking that total circumference and we're splitting it up into chunks the length of the radius. And so we can get 6 full chunks around, but then we're left with this awkward little bit left. But think about what we're doing. We're taking our circumference and we're splitting it up into chunks of the length of the radius. That means we're dividing it by the radius. And so when we do that, we see those r's cancel out and we're left with 2 pi, which is the number of radians in one complete revolution. So 2 pi is equivalent to 360 degrees. 2 pi radians is equivalent to 360 degrees, which means that pi radians is equivalent to 180 degrees. And pi is roughly 3.14. And so, if I draw an angle, I want to draw an angle that's 3 radians. If I draw something that is not a full 180 degrees, but slightly less than it, that right there is 1. I'm messing everything up. That right there is 3 radians. And I know it because 3.14 radians is a complete 180 degrees, so that right there would be roughly 3.